Let's do an example involving the law of sines, the triangle in which you're given two sides followed by an angle. So for example, let's say we have side A is 6, side B is 8, and angle A is 35 degrees. So based on the given information, we're going to use law of sines involving angle A and side A. So I'm going to use the given ratio for sine of 35 degrees over 6 to find the other things that we need. So because I have side B, I'm going to be able to find angle B. So using the given sine 35 degrees over 6, this will be proportionate with the sine of angle B over 8. So solving for angle B, cross multiply, so I have 6 sine angle B equaling 8 sine 35 degrees. So that the sine of B is 8 sine 35 over 6. Still solving for angle B, I would need to undo that sign, so inverse sine. Let's get an approximation. Make sure you got degree mode. So the inverse sine of 8 sine 35 divided by 6 is about 49.89 degrees. Okay, but keep in mind that when you did the inverse sine, that's only going to give you one output, but the sine is positive in 2 quadrants. So at this moment, what we have is 49.89 degrees. So this is B. I'm going to call this B1. But the sine is also positive in the second quadrant. So I'm going to take that B1 and map it over into the second quadrant to find what a second possible angle would be. I'll call this B2. So that's going to be 180 degrees minus B1. Okay, let's see what that is. So 180 minus 49.89 is about 130.11. So 130.11 degrees. So let's see if this is even feasible. Going back to the given information, I have 35 degrees as my other angle. So if I do A plus my B2, I would have 35 plus 130. That's 165. So this is possible because this is less than 180 degrees. So that means there is a second possible angle for B, which also means that there's 2 possible triangles. So what I need to do is separate this now into 2 problems, where B1 is 49.89 degrees, and B2 is 130.11 degrees. So there's 2 possible triangles here, so that means I need to keep going, and we're going to do this twice. I'm just going to do everything at the same time. I'll just work both sides. So I have angle B, so now I need to find angle C and side C. So since I have angle A, I can find angle C. So I'm going to take 180 degrees minus 35 degrees minus B1, so I'm trying to find C1, so 49.89 degrees. So then for C2, we'll do the same thing. So 180 degrees minus the 35 minus B2. So for C1, we would have 95.11 degrees. I'm going to say approximately because B1 was approximated. For C2, 180 minus 35 minus 130.11, we'll get about 14.89 degrees. Okay, so all that's left to do is find the sides. So C1, we can use law of sines using the given ratio of the sine of 35 degrees over 6. And this is going to be the sine of angle C1 that I just found. over side C1. Same thing for side C2. So the sine of 35 degrees over 6 will be the sine of 14.89 degrees over side C2. Okay, so solving for C1, cross multiplying. So I would have C1 times the sine of 35 degrees equaling 6 times the sine of 95.11 degrees, and then just dividing. So C1 would be 6 sine 95.11 degrees divided by the sine of 35 degrees. And side C2 will be 6 sine 14.89 degrees over the sine of 35 degrees. Okay, or approximately. For side C1, I would have about 10.42. For side C2, I would have about 2.69. Okay, let me show you why there's two possibilities. So with the given information that A is 35 degrees, they would both start out like that. So A is about 35 degrees. So then with B1, at the top we would have about 49.89 degrees. Something like that. For the second one, we had B2 is about 30.11 degrees, so it's going to be a lot larger angle. So it's kind of like that. Okay, so that's why there was two possibilities. If you take a look at it, this triangle on the left side here, which was side A, just kind of swinging in, and this side A was swinging out. So that's why there's two possibilities in this case.